Hello and welcome to the Controller Talk podcast presented by Danfoss North America. Our goal is to bring you information about using Danfoss controls in the supermarket and warehouse industry, specifically in the US and Canada. We're doing these twice a month for now. You can catch these podcasts on Spotify, Google Podcast, Apple Podcast, or as the saying goes, wherever you get your podcast. Subscribe to stay on top of releases. If you really want to punish yourself, switch over to the video version on our Danfoss North America YouTube page. Search for Controller Talk to see the video library. I'm Dave Yoder, along with Chris Brown. Well, Chris, it's almost springtime here in Maryland, and that means the children are out on the soccer field, daydreaming about maybe someday getting into refrigeration while the ball goes by their little heads. Are you still coaching soccer?
Nope. I had to give that up to the big dogs.
You retired.
Doing some football coaching, but no soccer.
No soccer. I did see your retirement speech online. Excellent. Okay.
Gotta follow the money.
Yes. Well, Chris, you'll remember from last time that the AKV valve was released in 1987. And this is a very common electronic expansion valve. And you'll also remember that you correctly guessed that more than 3 million of these have been installed so far.
Guess being the key word there.
A guess nonetheless, but it was a good guess. So AKV stands for Adap-Kool valve. In the Danfoss realm, Adap-Kool refers to technology that uses intelligent algorithms for controlling, including building a history of valve cycling that can be used if it detects a sensor failure.
Yep.
The AKV valve has 3 types, the AKV 10, 15, and 20. Nearly all supermarket cases that we deal with uses the AKV 10.
Right.
Each type can be sized for multiple orifices. The AKV 10 can be sized for orifices numbers 0 through 8. The bigger the orifice, the bigger the valve capacity.
Right. Yep.
Most sizing is done with our Kool Selector 2 software.
Yes, it is. Yeah, you can't go wrong with using Kool Selector 2. I mean, if anybody's used it in the past, it definitely beats pulling up a document with capacity tables on it and doing the math for subcooling and all that. So.
Right, because capacity tables can get outdated quickly. You have to add new refrigerants, all that good stuff.
Right.
Yep. So the software is available as a free download, and really anybody can use it, and it's actually pretty easy.
Yep.
So the AKV acts as the expansion device, and it's solenoid tight. So you won't have a TXV in the case. This guy will act as the TXV. And when the cooling is off, there's little to no leakage through that valve.
Right. Yeah. Nothing super sophisticated here, right? And so we've got the expansion valve, and on the inlet side of that valve, the liquid's coming into it. It's a normally closed valve when we look at the AKVs, which means unless we apply power to the coil, that valve sits fully closed. And that's one of the benefits. We'll get into some benefits probably later on here in the conversation, but one of them is the fact that this also acts like a solenoid valve in terms of when it's fully shut, you have no flow through that valve.
Right.
So the coil that sits on top of the valve stem, when voltage is applied through the coil, that allows the piston to open up, and you essentially have your liquid or your refrigerant that passes through the filter or strainer and then onto the orifice. The filter or strainer sits around the side of the valve body. Again, something we might touch on here in a few minutes, but that's something that can become a restriction depending on if there's some debris in the system or whatnot. When power is removed from the coil, again, it's just back to the fact that valve is closing off flow through the valve body. The flat surface of the piston just sits on the flat surface of the orifice inside of the valve, and that flow is stopped.
Right. Yep.
You start to get into some of the nuts and bolts of the electronic expansion valves. So a lot of people are probably familiar with the stepper style of technology on an expansion valve. These AKVs are what we call a pulsing valve, pulse width modulation. So again, it goes back to the fact that there's no position to the valves, right? They're either open or they're closed at any point in time.
Right.
And so sometimes some guys, and then with our controllers showing the opening degree of a valve, it can be a little misleading where a guy might assume that the valve's actually 50% open if we show that on our controllers. But the reality is, with it either being open or closed, we're taking small chunks of time. The default is 6 seconds in a lot of our devices when you look at our controllers. But essentially, we're looking at that small window. We call it a cycle, and depending on what the superheat is and maybe a few other factors, we'll decide how long within that 6 second window we want to open that valve completely for.
Okay.
And so when we want to open it, and let's say we are calling for a 50% opening degree in the controller we're using with the valve, and we're looking at a 6 second window, 50% opening degree would essentially correspond to opening that valve completely for opening that valve completely for 3 seconds rather, and then shutting off or killing your power to the coil and allowing that valve to close for another 3 seconds. And then process repeats itself every cycle, every 6 seconds. The controller will readjust depending on what the superheat reading is and how far it thinks the valve should be open. And that could be 4 seconds out of every 6 or 0 out of 6 if we feel like we're below our superheat target. So yeah.
Yep.
That'll fluctuate there. You might have some concerns about that sounds like a lot of opening and closing on the valve, right?
Right.
So how much wear and tear is it? How much life expectancy am I really going to get out of those valves? But yeah, if you remember episode 2, we talked about some of the life cycle counts on these valves, and you can get upwards of 50 million cycles on them before you can expect to see some failures, which you're getting a good lifetime out of them.
Right. Right.
So why pulse width modulating valves versus a stepper valve? I'd say there's a lot of, I've got 3 strong arguments that come to mind for me. One is we know when we deal with stepper valves, one of the things that we're always battling is calibration issues. The valve, you're dealing with hundreds or thousands of steps depending on the valve, and if you lose a few of those steps, now all of a sudden the valve's not where the controller thinks it is. We're not dealing with that with the pulse valves. Again, you're either fully open or fully closed, so we always know exactly what position the valve is in. And again, it eliminates the need for having any solenoid valves ahead of the expansion valves, since the pulse modulating valves are refrigerant stop when they're closed off.
Yep.
One of the benefits of the fact that it is that hard open and close, that hard stop, is it creates some turbulent flow in your evaporator, which maybe that doesn't sound great, but that actually creates some better heat transfer in the evaporator. So getting that turbulent flow through there, it's a bit of an energy saver in some regards too, just because of how it helps with heat transfer in the case. Okay. Yep. And then number 3 there is the opening time. So if you think about a stepper valve, you're talking, several seconds, probably usually over 10 to 20 seconds it could be to go from a full open to a full closed position on a stepper valve. The pulse modulating valves, we know in a split second we cut the voltage to the coil and it's closed off. So much faster responses in a situation where we have superheat constantly changing and we need to be able to adapt to that. Yep.
Yep. So that turbulent flow you talked about in the evaporator, I think that's called an annular flow.
Yep.
Yep. You have to be careful with that word.
Yeah.
But annular is the key word there. Gotcha. All right. So from 1987 until about 2018, the AKV was virtually unchanged. And you had the AKV for your HFC refrigerants,
yep.
The AKV-H for the higher pressure stuff, and the AKV-A for ammonia.
That's right.
With the original stem and armature, the piston would drop out of the stem if you opened the valve. So that's just something to note because there's a difference coming here. Yep. In 2018, the AKV-P was released to replace the AKV and the AKV-H. So it was designed for a wider range of pressure and had a quieter operation when it would snap open or snap closed. Yeah. On the AKV-P, if you remove the stem and turn it upside down, that piston will gradually slide out because they have everything with tighter tolerances.
Yeah, and that quieter operation too. I know when I've been in stores where they were just starting up and there was no product in the cases yet, you walked in the store and you could hear the clicking left and right.
Right,
now,
right.
Once the product gets in there and some of the other white noise in the general public building, then that really died off and most people couldn't hear it, but definitely something you heard if it was a brand new store with not a lot in there at that point.
Right, that ambient noise made a difference.
Yep.
No crying babies, none of that stuff. Yeah, you could hear clicking anytime you walked by a case.
For sure.
Yeah, yep. Then you add in a few paddle fans or whatever, and maybe some Muzak, and you kind of tune it out really quickly.
And so if somebody didn't know to listen for it, a regular shopper in a grocery store, they're not even going to know.
Right.
It's
Just
there,
nerds like us would be listening for it.
Exactly.
Yeah.
Exactly.
So, Chris, do you know about Helga?
I do not know about Helga.
Well, it might be a rumor, it might be legend, but I've been told that this lady is very strong. And she's also very good at what she does as a Danfoss employee. I think she's the lady in final assembly at the factory that tightens down the stem on these valve bodies.
I'll have to look for her next time I'm in Denmark.
Yeah, she's famous over there, I'm sure. But she hates leaks, and she tightens these things down tight. And I've had big guys struggle to get them open, but you can get them open.
Yeah.
I took one of these apart with the help of my neighbor Bruno, of course. And so when you unscrew the valve stem, the piston will drop out like on a regular AKV. Other than the AKV-P, it's very gradual, but it will come out. And inside the valve, you'll see the orifice, and then the strainer is kind of around it, on the sort of against the outside of the valve body itself.
Yep.
If you start looking closer, you'll see some laser etching on some different parts of the valve. The orifice itself down in the valve has a number etched into the top of it, so that if you're holding an orifice, you know what number it is.
Yep.
And the base of the stem, where it meets the nut, has etching on the top part of it for the part number of the valve and the original orifice size.
Yep.
So all this is on top of the nut, so you don't have to remove the coil to see it. You just have to, well, you do have to remove the coil, but you don't have to remove the valve to see it.
Correct.
Yeah. So some things to know about putting the valve and the coil back together. There is a crush gasket that is supposed to be replaced anytime you remove the stem. There is a rubber O-ring that sits between the coil and the base of the stem, and its job is to give you a nice fit between the coil and the base of the stem and prevent moisture from getting up into the coil.
Yep.
If you run the valve without the O-ring, you're kind of asking for trouble, because it's not going to fit quite right, and you could get moisture up into the coil and burn that out.
Right. It's just before I go on to the next technical part here, you just name drop Bruno. You're probably past your Disney movie days at this point in your career.
I am. Yes, yes.
If you had watched Encanto, you would know we don't talk about Bruno.
Oh, my mistake. Yes. My kids are both driving, so we haven't sat down as a family and watched Encanto.
There you go.
Yes.
But yeah, back to the topic at hand here. So the valves, we've really focused on a lot about the valve body, the application of the valves, but the second piece of the puzzle is the coil on top of the valve, right?
Yep.
So we don't typically, you may run into a few situations where we offer some things with a valve and coil combination, but by and large, we don't sell the coils with the valves. And that's because of the flexibility we need to have for the electrical circuit that's been pulled down to the cases. I think probably you could argue a majority of the time we see a 120 volt coil that's used in most of the reach-ins and most of the standard display cases. Walk-ins, it can get a little bit more of a 50-50 ratio, where you might see a 230 volt circuit there. Mm-hmm. And so you're going to go with the 230 volt coil to match. We offer 24 volt coils, but again, you want to just pay attention to the case controller you're using. 24 volt coil means that the amp draw is going to be higher on it, and just being careful there that you're not using a coil that's going to draw too much current that the relay on the case controller can't handle it.
Right.
We also get into a little bit of different coils for specific applications like CO2. And so we have some higher amperage coils that need to be able to accommodate the high pressure differential across the valve when we're looking at a CO2 application. So yeah, just if you have any doubts, I'd say on an HFC refrigerant system, it's just a matter of lining up your voltage. But on a CO2 system, just keep in the back of your mind maybe that there is a second layer to it for that pressure differential that could come into play.
Yep.
And then we have some different connection types. We have a conduit type that's just two wires coming right out of the coil. We have a junction box style where you can kind of land the wires inside of it. There's some DIN plug styles that I don't see too much of, but they exist too. So yeah, if you're on our product store, you're going to see dozens and dozens of different options, but you can filter it down to what you want pretty quick just based on the voltage type and connection type.
Yep. Okay.
So as far as landing, what would be two wires, whether they're already coming out of the coil or whether you're landing them, but you've got two wires essentially that come out of it to go to a controller. The important thing there to keep in mind is we're not just taking those two wires and landing them right on our relay of our case controller. What we're doing there is one side of that coil is going to be your neutral that you take back to that side of the circuit. But the other wire, the hot wire for the coil, whatever voltage it is that we need, we're going to take that to our case controller. And so one terminal in the case controller would have, let's say, 120 volts if that's the type of coil we're using. And then the case controller is going to switch that 120 volt feed on and off depending on whether or not we want to open the valve and pass it through to the second terminal to go out to the valve.
Yep. Okay.
You want to make sure the coil's properly in place. So I think years ago, the style of the coil, it was something you kind of had to push down in and hear it snap into place. And maybe some people didn't know that and weren't pushing it all the way down, and it would become loose and not open the valve properly. Here in the last few years with the last redesign we had of the coil, now it's a bit of a clip on there. So you clip it into place to kind of lock it in. So yeah, just something else that you want to pay attention to there. And then just one quick note on the 120 volt coils, for example, if you ohm them out, you should be getting somewhere around 75 ohms. So one way to check and see if you have a coil that's maybe burned up if you're troubleshooting the system.
Yep. Okay. And that clip on top of the coil, it's clipping itself onto the top of the stem, right?
That is correct. Yeah, it's not making direct contact with the valve in any way.
Right. Okay. And when you're mounting it, I think you're okay in any position except for the coil on the bottom, right?
Yeah, if you just kind of look at a plane, you don't want your valve body to be anything below 0 degrees or 180 degrees. So basically, if the valve coil is below the valve body, you're going to run into some issues there. So basically flat or somewhat vertical, you want the valve body to be facing.
Right. For most people, it's not an issue because they're getting a case that's new and it's got this already installed. And
exactly. The OEMs know what they're doing there.
Right.
And yeah.
Okay. So when it comes to the orifice, the orifice will determine the valve's capacity. And we said that they're numbered from 0 to 8 on an AKV 10.
Yep.
And the case OEM normally sizes the valve based on the case conditions using that Cool Selector 2 software we talked about.
Yep.
And they seem to be pretty good from what I've seen at doing the sizing by now, because it's been like 10 years since I've seen a store where it really got messed up.
Yep.
And maybe somebody was guessing and didn't know how to operate it or didn't know that they could size it with software. But it's been quite a while. Since that's had to be pointed out. But if you do decide to remove the orifice, or if you want to try a different size, then you can just get in there with a 10 millimeter socket and break that loose, and then unscrew them with your fingers.
Yep.
So one of the things that makes guys scratch their heads when it comes to these valves is how to troubleshoot them and when you have to open it up.
Yep. And just real quick, one other point on the sizing of it that these OEMs are doing. There's no there's some overlap in the capacities between the valves. So it's not that there's only one right answer sometimes when you're looking at a given case and choosing a valve for it. So sometimes there could be 2 or 3 different sizes of the AKV that could work for the same case.
Okay.
So yeah, there's a little bit of flexibility from that standpoint too.
Okay.
But yeah, as far as the troubleshooting, you're normally looking at one of 3 things. The valve's not feeding refrigerant into the evaporator at all. The case maybe isn't pulling down as quick as you think it should be after defrost or on the initial startup, or the case is running too cold and doesn't seem like it's stopping refrigerant flow when it should. So when we look at that first situation there where the valve just isn't feeding at all, obviously you want to check your power to the coil. Now that could be no power from the circuit that goes to that line side of the case controller, or that could be no power out of the case controller going down to the coil itself. If it's that second scenario there where it's no, or basically your power to the case controller is okay on the line side, but not coming out of it on the load side to the valve, that would normally point to there's something in the case controller that's telling it not to open up. So is it low superheat? You want to go in and make sure your transducer and suction line temp sensor are reading accurately, to make sure it's not a low superheat that's closing the valve down. We do have some safety settings in our case controllers that I'd expect are pretty universal if you look at other people as well. But if suction pressure gets too high, we don't want to continue to build that pressure up by feeding the evaporator, so we could shut the valve down because of that reason. And then the case controllers offer some kind of auxiliary things with digital inputs where you can just shut the case controller down on any, really any digital closure that you feel you want to.
Yep. Okay.
Relay could be bad. So we have a solid state relay on most of our case controllers that feed the coil. Easy way to check that out would just be to jump out the plug that the valve is landed on. So just kind of bypass your line voltage right to the load side, and if the valve opens up, then we know it's could be the relay. And I think a secondary part of that would also be checking what the opening degree is calling for in the case controller. Because if we're saying we're 100% open, but we're still not getting voltage to the coil, then the case controller thinks it's open, but we're just not getting that voltage down there.
Okay.
Coil could be bad. So we talked about ohming that out. So that'll give us an idea if we have a burnt up coil or not. And then you've got the mechanical aspect to all this too, right? I mean, if we don't have enough liquid to feed to the valve, then it doesn't matter what we're doing there. It's not going to open up.
Right.
So low liquid, low drop leg pressure to not have good positive differential across the valve to feed refrigerant through there. Those are some of the things that you're looking at. If you're on the startup and you suspect one of these problems, you can always turn off some other cases that are nearby just to see if that all of a sudden gives you the liquid you need to feed the case that you're kind of troubleshooting.
Yep, you can turn off the hand valve if it's got one, or you can just make sure that case isn't feeding nearby.
That's right. Yep. So the other situation, if we got a case that's slow to pull down, and on that one, you can kind of start the same on the mechanical side. Look and see what your drop leg pressure is looking like. We don't want to jump right to saying that the valve's in size properly on these pull downs, especially if it's a store that's been in for a while. Again, like you just mentioned, the OEMs are pretty seasoned in how to size these things. So most of the time it's unlikely that it's going to be a sizing issue. If it does come to that though, Cool Selector is a pretty easy tool to use. It's always something you can throw the conditions for the case in there pretty quick and see what it looks like. If it seems to be way undersized or not, it gives you a load percentage in the software. And then we want to make sure the case isn't iced up. So, I mean, a pretty easy check there, right? Just we can see if it's pulling down slower and slower over time. If you kind of look at the history and the system manager that's tied to all this, if one is being used, then that might give you a feel for the fact that slowly over time that ice buildup's getting worse and worse, and that's why we're not pulling down as fast. Yep. If you kind of ran through all those things, then you might get to the point where opening the valve up makes sense. So whether you have to pump the system down first or just isolate it with some ball valves that you have in line there. You want to get this thing isolated so that you can unscrew the stem and check for dirt in these strainers that we talked about that are in the valve bodies. Pretty readily available if you need some spare strainers. So we sell them. A lot of the distributors we deal with are going to have these in stock for you, but we sell them in sets of 10. So 10 strainers and 10 of the crush gaskets. It's part number 068F0540, just to kind of mention it here now in case anybody's taking notes.
Right.
And so, yeah, you'll want to replace that gasket anytime you're opening the valve up to take a look at this thing. Some of the guys are a little worried about it, but again, it's a real simple process just to open that valve up once you've got it isolated. And get in there to whether it's changing the orifice out or just looking at the strainer, you'll see when you've got this thing cracked open that everything's sitting right there for you to kind of access and pull out and replace if you need to. And just keep in mind if you're doing that, if you're kind of opening the valve up and part of that being taking the coil off of the valve stem, that we want to make sure there's no power going to the coil, because again, that could burn up, that could get hot and burn up if we're just leaving it sit there idle without being connected to the valve.
Yep. Okay. Now, for a case that's running too cold, you want to see if there's power to the coil when there shouldn't be. So you'll need a voltmeter for that. You want to verify that there's no power to the coil. You can see if there's no power to the coil, see if the case temp starts to rise, which it should. You can remove the coil from the stem to see if there's any difference in the case. If a piece of dirt gets in there, gets stuck between the bottom of the piston and the top of the orifice, then that could do it.
Yep.
You would think that a piece of dirt wouldn't get stuck in there because there's nothing to kind of catch it, but you never know until you get it apart.
Yep.
You just need to carefully remove the stem and check for dirt on top of the orifice. There's, I think it's a nylon material that comes down against the orifice, and maybe something could get stuck in there.
Right.
If you've got enough dirt in there.
Yep. Seen it happen plenty of times before, so it's definitely possible.
Yep. So, Chris, we get this occasional call about distributors, and it's about distributors that have an orifice inside, and there's a pressure drop through that orifice in the distributor.
Yep.
And from our standpoint, we wouldn't normally think that you even need one in there.
Yep.
But a lot of times there is one in there. And you end up with, you can get icing on the distributor, you can get flashing, and what are people supposed to do about that?
Yeah, so I mean, a couple things to point out here. One is when the OEMs or anybody that's in the design phase of this is sizing the valves, we keep mentioning Kool Selector and how great it is. It does give you a feel to account for whatever pressure drop is going to be in the basically associated with that distributor orifice if there's one being used. Sometimes you'll get a situation where we don't necessarily know exactly what that pressure drop is if we're trying to size it or verify what the valve selection should be in the software. I'd say it's probably pretty safe to assume somewhere in the 35 to 40 PSI ballpark is a figure you can use in the software if you're checking this out. Again, like you said, I mean, that frosting up will happen in between the valve outlet and the distributor inlet because it's a restricted area where the refrigerant's boiling off, and you're going to see some frost or ice build up on it if that's happening. One of the quick fixes that you can do, it's not an exact science, right? But if you open that, you get inside of that distributor, then you can either remove that orifice entirely or if somebody's drilling it out and basically, eliminating or severely dropping what that pressure drop would be through that distributor orifice, then those are two things that can help allow refrigerant to flow through there properly and remove that frost and ice buildup if it's happening.
Right. So the mechanics will have to decide for themselves what works best for them, whether they remove the orifice or whether they drill it out. Yep. Because if you drill it out, you're going to have little metal pieces there to deal with, and you just have to make sure you get them all.
Yeah, I'm not completely up to speed on are all of them removable or some of them kind of fixed and you have no choice but to drill them out. But yeah, if you can just open it up and take it out with a pair of needle nose or something like that, that's probably the safer route to go.
Right. Okay. All right. So there's a few other things to know about these valves. There is a round magnet that you can use to manually make the valve feed. So you just take the coil off, you slide this magnet on over the stem, and then you should hear the valve open. Yeah. These are usually, the ones I've seen are like a blue plastic on the outside, and they are sold under a Danfoss part number 018F, like Frank, 0091. And they can be kind of handy to have in case you need one. Yeah. There's also an AKV 10 PS for larger sizes, like 4 through 8, but it's a servo-operated valve.
Correct.
Yep. The AKV 15 and 20 are for much larger evaporators and have some different configurations internally. So that's more of industrial size usually.
And those 15 and 20s, just to be clear on those, they haven't moved to this proportional or P design that we have with the AKV 10s. So you won't have an AKV P15. It would still be the original AKV.
Those are just a tried and true setup that they always used.
Right.
Okay. Yeah, so these are designed for one flow direction, and we talked about mounting for those.
Yep.
So it shouldn't be an issue unless you've got to install one where you're maybe taking out a TXV and now you're installing one of these.
Yeah. Yep. And it would be tough for a lot of time for it to even mount it upside down in a case because that evaporator's sitting right there at the bottom of the case already, and you don't have much choice but to go either parallel with it or up.
Yeah, that's true. So we don't recommend these for a one-to-one system like a little condensing unit. They seem to work better on a parallel compressor rack setup.
Yeah, and that just goes back to the pulsing technology. I mean, we're shutting things on and off, and so in a system where you've just got that one evaporator and the compressor and the fans on the condenser side, it creates more bad than good by just completely stopping that flow and then starting it again.
Okay, yeah. It's a little bit what they call over-controlling.
Yep.
Yeah, okay. So that's all we have on the AKV electronic expansion valve for now. So in this part of the podcast, I throw a question at Chris to test his knowledge. So, Chris, can you testify, as usual, that based on the statutes and laws of the state of Maryland that I have not shared the question nor the answer with you ahead of time and you have not tried to bribe me or anything like that?
Did think about sliding you at 20, but yeah.
Well, you're going to have to do better than that. Yes. Okay. So, are you ready for this week's question?
Let's do it.
Okay. It's a two-part question, once again about numbers. And the question is, what is the torque spec for the AKV 10 Orifice? And I'll need the answer in foot-pounds of force, if you don't mind.
Yeah.
This is for the Orifice.
Yeah, for the Orifice.
Because I know you carry a torque wrench with you at all times.
And if I try to Google it right now, everyone will hear my typing.
That's right. Dead giveaway.
I got to take a strong pass on this one. I'm not sure.
Taking a pass. Okay. This is where you needed a lifeline.
I did.
The correct answer is 7.4 foot-pounds of torque.
Okay.
Sorry, foot-pounds of force.
Is this where Helga comes into play, or?
The next one. The next one. Yes. How about the torque requirement or the torque spec for the stem on the AKV 10?
For the stem.
You should surmise that it'll be a higher number.
Yeah, I'm just trying to. Do I triple it, quadruple? What do we do? Let's go 20.
I'm sorry, that's incorrect. You're a bit low. It's actually yes, it's 55 foot-pounds of force. There you go. Is the torque spec for the stem.
So 2 Helgas. Okay.
That's right. 2 grunts with Helga and you're there. All right. So we'll call that 0 for 2.
Hey, I'm here to disappoint. So
okay. So now let's move on to some listener mail. How about it? Yes.
Much less stressful than those questions. Let's do it.
Okay. All right. So by now, we've had a couple episodes hit the airwaves, and we're getting some mail back. We've already got our first hate mail out of the way. We're getting some spam. That's always nice. But today's listener mail comes from Mike in Muncie, Indiana. And his question is, does Danfoss make anything in the U.S., or does everything come from China? Well, we've got some answers on that. So I did a little digging on this one, too. So it turns out that in the U.S. and Canada, Danfoss has about 5,800 employees.
Okay.
And that includes Eaton Hydraulics, which Danfoss completed that purchase last year.
Correct.
So if we quickly run down through it by the numbers, there's over 25 locations in the U.S. where Danfoss is making product. Some of those include the turbo core compressors that come out of Tallahassee, Florida, the drives and cabinets. There's a lot of sales and sort of tech support work comes out of Loves Park, Illinois, and a lot of cabinets come out of Milwaukee.
Right.
Yep. Beer and drives come out of Milwaukee. Everyone knows that. Then we have Power Solutions, which is out in Ames, Iowa. They do a lot of drive gears and joystick controls and software and things that are in mobile applications like combines and backhoes and all sorts of things.
John Deere.
That's true. Yep. And then the other thing that's going on in the U.S. is silicon power. There's a lot of these little components made up in Utica, New York that are used in electric vehicles. So that's just a cross-section of what's going on in the U.S.
Yeah, there's some manufacturing here for sure.
That's right. All right, so in upcoming episodes, we'll cover common problems you might run across, individual controller types, and all sorts of other things. Thanks for listening. Our studio and video engineers are Michael, don't call me Mike, Beckerman, and Jordan the Man Larsen, who is absent today. Collectively, we call these guys Michael Jordan. Our audio engineer is the international man of mystery himself, Raul Garcia. Until next time, for Chris Brown, I'm Dave Yoder. Stay cool.